day. A good day is you get 100 on your quiz, you understand the concept, and you get your work done in class. That's a good day. Let's make it that one of those. Okay, financial applications. Now, most of you have heard of compound interest. And the way compound interest works is if you had $100 at 10% interest, at the end of the year, you'll have $110. The next year, that 10% will be on your $110. So it's compounding. If you do not take your money out, you'll make interest on your interest. Yes, I am. Thanks. So that's what this exponential thing is, right? And it's going to come from the main formula, A equals P 1 plus I to the n. Okay? Now, A, hold on. A, yeah. So this stands for your amount. This stands for your principal, which we would call initial amount. Okay, this is your interest rate. And this is your compounding periods. Okay, so you've probably all seen this formula before, right? Compounding periods. Okay, and it's written down here too for those that cannot read my writing. Compounding periods. Okay, so this is an exponential equation because n is your exponent, number of years, number of compounding periods. Okay, so that's a formula that we're going to get on our study sheets with, make sure you've pointed everything out. And here are some terms that we have to know. Annual is 1 time per year. That's how many times per year. Compounded annually is 1 time. Compounded semi-annually will be 2 times a year, aka every 6 months. Quarterly is 4 times a year. Monthly is 12 times a year. And daily is 365 days a year. So we have to know all of those because when we do these, if it's compounded semi-annually, I will do this question differently than if it's compounded monthly. Okay? And I've got a quiz for you that next day that will have different types of compounding. Okay? So we're just going to get doing these because these are just a matter of what do I put where? Okay? Now, Andrew, invest $100. Determine the values of P, A, R, and N, and T for each situation. An annual interest rate of 4% compounded semi-annually for 6 years. Now, Andrew invests $100. That is my initial. Okay? So this is my P. Okay? Annual interest rate of 4%. So your interest rate is always I, which in this case we always move the decimal 2 to the left, 0.04. Because this means 4 over 100, 4%. Now, compounded semi-annually, what number is that? 1, 2, 3, what? 2. Quarterly is 4. And for 3 years, which is my n. Okay, so let's write down our formula. A equals P 1 plus I to the n. So A, the amount we will have, equals the principal, 100, times 1 plus, what is I? 0.04, and we're going to put that over 2. Times how many years? 3 years times 2. Okay, so semi-annually, I will put a 2 there, and I will put a 2 there. Why? Because we are going to compound in 3 years. I will have 3 times 2 compounding periods, won't I? Because it's twice a year now. So it'll actually be 6 compounding periods now. And this is annual interest. So we need to divide that by 2, so we always get semi-annual interest. So whatever this word is, we will put here and here. If this was monthly, I'd be putting a 12 here and a 12 here. If this was daily, 365 there, 365 there. Okay? So we're going to be very deliberate when I'm teaching you this stuff, that we stay consistent. Not once in a while we'll put a 2, not let's put a 2 here and an 8 here, right? That would be like, right? Just make sure this word gets put there and there. Okay? So I just want you to try on your own to put this in your calculator, see if you get the right answer. Okay, that's how much money you will have at the end of 3 years. See if you can get that. Which isn't always easy, right? Sometimes we're not getting why I'm not getting the right answer. Okay, so I want you to just see what I did there. You have 100. 100 times 1 plus 0.04 divided by 2. Do you see I only want the 0.04 divided by 2? I do not want all of this divided by 2. Close my bracket to the exponent. Do you see what I did here? I always put my exponent in brackets. Okay? And hopefully you get that. Okay, you need to look at my screen and make sure, the screenshot here, that you have exactly what I have, or else, of course, you probably will not get it right. So 100 times 1 plus 0.04 divided by 2, shut my bracket to the exponent button, open bracket, 3 times 2. So we always want to make sure we put this in brackets. The 1 will always be there. Yep. Okay. Or the next bullet. We have 6 3/8%. That's not nice, is it? I would like an idea of how to deal with that. Yep. Okay. Get into a decimal. Okay. Now, this would be 6 point. Now take 3 divided by 8. Okay, so we want to go 3 divided by 8, and what do you get? 3, 7, 5. Now that's 6.375%. Divide by 100, what would you get? It's the same thing as moving 2 decimal places to the left. 0, 6, 3, 7, 5. Okay, so that's our first beast. The 6 Do you see how I just keep the 6 there? And then I put point the fraction converted. 3 divided by 8 is 0.375. Then move 2 decimal left. So I get it into decimal. Now, let's write out our equation. A would equal, how much money am I starting with? 100. Bracket. What goes next? 1 plus 0.06375 divided by 12. Close your bracket to 2 times 12. Okay? So we want to kind of be deliberate right now and circle the 12s and circle the monthly and go like this. Okay? Because I don't want anybody going to their notes going, how did I get that 12? I don't remember how I got that 12. Those 2 arrows will quickly remind you how you got those 12s. Now, okay, we are going to go 100 bracket 1 plus 0.06375 divided by 12 exponent. Oh, but what happened? Bracket. Crap. I tried to move it and it erased everything on me. 100 times 1 plus 0.06375 divided by 12. Exponent 2 times 12. Okay, does that look right? So you will get A to equal. Oh, I didn't even write down the last example. I just, okay, for this one, A equaled 112.62. Why am I stopping at 62? Because that's money. Yep, that's the money. 113.56. Now, same amount of money. For 2 years, I can make more money off of that interest rate because it's bigger and it's compounded more, right? The more compounding periods, the better for you. But the more compounding periods when you take out a loan, the worse for you. Okay? So what you're looking for is lowest interest rate and higher less compounding periods. How can one bank look more competitive to another one? They will offer a lower interest rate. Does not make you look better? Well, if you were giving a loan, I mean, right? But they will counter that by putting higher compounding periods. So they get you from across the street, you come to them, and they'll actually make more money than if you would have stayed, because maybe you had less compounding periods. So you got to know 2 pieces of information, not just what the interest rate is. Okay? If it's a lower interest rate but they compound daily, the other one may have a little bit of a higher interest rate but they compound monthly, right? You may be better off with them. Okay, next one. $500, 8% per annum. This will always be per annum, okay? Just so you know, the 8% is always per year, compounded annually for 2 years. Determine the accumulated amount. So A will equal P. What am I starting with? $500 times 1 plus 0.08 over 1. Now, I know what you're saying. Why do I have to do that? I'm being deliberate, aren't I? I'm actually putting 1 to show you annually, annually, annually. Okay? So if we're consistent, let's always put something there. I know you're thinking, well, 1, that's like a waste of my time. But it's getting you to be looking. Right? So, what are we getting for an amount? How much? 0.20, right? there was a, it's kind of an urban legend at this point, but there was a guy that, say that you got a, you have your money in the bank, and they're giving you interest, and your interest payment would come to, say, $58.263. Now, how much will the bank give you? 58.26, right? Now, who's going to go and waste their time calling up their bank going, whoa, 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 you owe me 0.3 of a cent, right? So who gets that? The bank. Now, if they had 1 million customers with millions of dollars, those add up, right? So that's what the collective, but there was actually, the reason I bring it up, there was actually a guy that worked at the bank that he was stealing all the 0.3s and 0.2s. So the bank didn't even see it, right? Because the bank is not going to see 0.3 or 0.2 or 0.1 off, right? But, so that's maybe the urban legend, but the one thing I can guarantee you is not an urban legend is the bank keeps that 3. I guarantee you that bank. So no, that's 0.3 of a cent. Okay, so you know this is 2.6. 2.7 is 1 more cent. This is only 0.3 more of a percent or of a cent. So you're thinking they're only making 0.3 cents off me, but if they've got millions of customers and they have millions of dollars, everybody's 0.3, right, adds up pretty fast. Right? Yeah. Yeah. They don't charge you. If you have money in, they'll give you like 1.5% and they'll lend your money out at 8%. Okay? Banks do not go broke. Okay? They know what they're doing. Now, suppose Will invests $1,000 for 10 years. If he earns an annual interest rate of 7.75 compounded monthly, determine the total interest he earned over 10 years. Now, this one's tricky. Okay? I want you to put an asterisk there because this one is tricky. They did not ask for his total amount. He wants to know the total interest he earned. Okay? Now if you look at all of these, okay, you can see how that wrecks a class, right? In example 2, how much interest did he make? No, that's his interest rate. How much interest did he make? 583. Did he make that much? How much did he start off with? 500. He now has 583. Did he make $583? He made 83. 83.20 is his interest. That's what he made. Okay? The one above, how much did he make? $13.56. That's the actual interest he made. Okay? The one above, he made $12, right? If you put in 100, right? And then at the end of the year you take out 112, do you go, "Ooh, I made $112." No, you didn't. You put in 100, you made $12, okay? So and not only that, you have to pay tax on that $12. You do. There's not a minimum. Well, you know what? There probably is, yeah. There probably is where the bank will look and go, okay, for us to mail this letter will cost more than we're going to get from them. But once in a while, I don't claim the interest I made, right? But they always find it, right? And then they send you a letter. Oh, yeah, you didn't send that interest you made? Yeah, you owe us $5 or whatever. It's like, oh, fine, here's your $5. There. But, hey, if every Canadian they get $5 out of, right, that's why they do it. Now, so total interest he earned, get very, get almost heightened with that question. That's not the amount he now has, okay? We know he now has $583, but he did not make 583. Gentlemen, guys, let's watch in here. Okay, so let's do this one. Get the formula down. A equals P1 plus I to the n. Okay, what are we starting with? $1,000 is what I'm starting with. 1 plus, what is my interest? 0.775, right? Okay, am I dividing this by anything? Why? Okay, so monthly, we're putting a 12 here for 10 years, so we're going to put a 12 there. And again, let's just draw our lines, because they're notes, right? And we do want to figure out later where do we get those 12s from. Okay, let's put it in. Are you writing this stuff down? Yeah? What did you get? Okay. So what does that stand for? Did he make that much? He has that much. How much did he make? So here's where we're going to put the asterisk. Interest equals, what would be the formula for interest? A subtract. Awesome. That's exactly what it is. You just came up with your own formula. So interest equals A is 2165.19 minus the principal. Like, that's how much I had to put in to make that amount of money. So 1,165.19. Okay, this is my interest. Okay, and that's why if you had the restraint, if you did win $1 million, do not spend it. Just put it in the bank, wait for 1 year, and at the end of the year, it's 6% interest, right? You could just live off the interest every year. If you spend that $1 million, it's gone. But if you leave that $1 million in there and every year just take an interest payment of 60, 70, 80,000, right? And then the next year another 80,000 come, another 80,000 come, okay? You would always keep that 1 million, right? But, how many people would have that restraint to say, okay, can we wait 1 year? Many people would just, yeah? There you go. So let's just, for the fun of it, let's do this same exact thing. Let's go 7.75, because you do, the more money you have, the bigger interest rate you get. So let's just try that for the heck of it. Let's say you won $1 million. So $1 million. Okay, let's put it in an account that we make 7.75, 0.775, and let's do a monthly. And let's just go for 1 year. Okay, you win the $1 million, and you're like, okay, I'm going to suck it up. I'll just put it in the bank. And at the end of 1 year, what would I have? That's 7.75% interest. It's always fun to dream, isn't it? $80,000 for doing what? Nothing. My favorite kind of job in the world. Okay? That is free money. Now, you could work at McDonald's and do that and make, over $100,000 a year, right? Or you could do, hey, you're like, you know what? I just want to do some job where I work 3 hours a day, right? But, $80,000, that's for the rest of your life. And that's like, hey, maybe you are going to not just quit your job. So if you have an $80,000 a year job, now you got 160, right? And that, That's off $1 million. Yep. Yeah, and that's how RSPs work. People put their money into RSPs, and they're just gaining all this interest while you're sitting there.
Yeah, just imagine winning that $60 million jackpot and putting that in the bank for a while.
Yeah, yeah. I would pay tax on that 80,000. Yeah. Well, you just wouldn't be paying tax, but you'd pay like almost a third of it would be gone. But anybody that says I make 100,000 a year, I guarantee their take home is about 65. Okay, so when you say you make, 100,000 a year, a little over a third you'll pay in taxes and pension and CPP and EI and all those things, right? Like you got all those deductions, right? But for doing nothing, 80,000 a year isn't a bad way to go, right? The thing is, many people get that million, they blow it, and they have nothing after. Like I think, over 90% of anyone that's won the lottery is bankrupt, right? And you look at Mike Tyson, who had $850 million at one time. He had nothing, right? Because he's like, okay. Michael had the opportunity to invest some money for 5 years, compounded quarterly at 6% interest. How much does he need to invest so he has $5,000? Okay, so here's the other thing. You want to see how much do I need to put in so I'll get $5,000. So what is the $5,000? That's my end. My amount. That's what I want. That's what I want to be able to take out of the bank. It's not saying I will make $5,000. Right? I want $5,000 at the end. Okay? So we'll write down our formula, which hopefully by now you're kind of remembering. Okay, so I want $5,000 equals the principal I don't know. I'm trying to find that out. Like, what do I need to put in right now? So 1 plus, what's my 0.06? Am I dividing that by anything? Quarterly, yes. 4. Okay, and that 4, now 5 years, 5 times 4. Again, I'm circling the 4 to make sure that's there, and it comes from the quarterly 4. Now what I want you to do, we're going to leave the 5,000 on this side equals P. What I'd like you to find is this answer. Just this that I'm putting in the box. Okay? So bracket 1 plus 0.06 divided by 4. Shut that bracket to the exponent and open your brackets because 5 times 4 needs to be together. Okay, now you want to be careful here and do not round too much. In fact, be almost over cautious of it, that we want to be able to put as many. So we should be getting like 1.34686. And you can put a ... if you want there showing. I'm not even rounding. I'm going to keep it that way. Now that's your answer, right? You can go 5,000 divided by answer, or you can just plug it in, 5,000. Because we're going to divide that out on both sides, aren't we? Divide out 1.34686 to get it out of there. Well, we'll do that to both sides. Right? Then it's gone. Okay, so how much money would you put in 5 years ahead of time? So in 5 years, I will walk out now. So $3712.35 equals what letter? P, which stands for the principal, the initial amount. So I think the only thing we got to watch when we do these is what's going where. What letter is going to be that one, right? Because that's where we can mess up. Megan needs $25,000 in 8 years for a down payment on a house. The bank is offering 5 5/8 interest per annum compounded monthly for 8 years. How much does Megan need to put away so she has $25,000 in 8 years? Okay, so let's write down our formula. A equals P1 plus I to the N. What kind of stuff do I know? I know my A, good, is 25,000. Again, this one is asking for what do I need to put in right now? Okay, the old crystal ball. What do I need to be able to put in? 1 plus. Now this we're dealing with again. That's going to be 5 point, and we're going to take 5 divided by 8 to get the decimal. And you got 625. So it's 5.625%, correct? Which would be, when I put it in here, move it 1, 2, 0.05625. Am I dividing it by anything? Monthly equals 12. Dividing by 12. How long? 8 times 12. Okay, so as you can see, we're into this scenario again where we need to find the box before we go and do anything past that. And I'm getting, okay, and just put a few 6's down and you can put dot, dot, dot. Now how do I solve for P? Divide both sides by 1.56. Again, we're doing all this work today for one question on the diploma, but that's kind of every day, right? And sometimes we'll be doing the whole day, and but you know what? They're usually really good. They'll get at least one question for every day we do. So what equals P? 15,957.47. We want to put the dollar sign equals P. So she would have to invest pretty well 16,000 to have 25,000 in 8 years, right? So I mean, this is all like really interesting stuff when you start getting into it. You know, people don't realize that if you were to buy a $500,000 house, and if you were to get a 25-year mortgage, because that's what people usually get, 25-year mortgage at, say, 7% interest, by time you were done paying for that house, you will pay $1 million for that house because of all the interest. So if you want to pay off a loan over many, many, many years, you will almost double what you've paid for your house. So in 25 years, if you don't get $1 million for your house when you sell it, you've actually lost money. But people most people have no idea what's going on behind the scenes. They pay their mortgage payment. The bank gives them a lot of incentives to be able to pay off their interest or their mortgage early. Most people don't take it. They're like, I like the payment, keep it going, it's all good, right? But now you know why banks don't lose money. Okay, what's that bank doing? It's nothing. It's not doing anything. It just has the ability to lend you $500,000. So they always say it takes money to make money. It's absolutely true, right? Like if you have $20, put it in the bank, you're going to be pretty disappointed after 10 years, right? Now if you 200 million and you put it in the bank, same trip, Okay, you did the same amount of effort as the next person, right? But it takes money to make money, right? You talk about investments, you talk about, you know, blah, blah, blah. You can go on and on. Yes?
Yeah, like when we did the what happens if a million after 1 year, like I mentioned the, I remember there being a $60 million jackpot a little while ago, and
Yep.
I did the math for that,